All right, we're ready for chapter 3, which is called Lift and Lower. This chapter is all about how levers move loads. So in this chapter, we're just studying one simple machine. Let's keep it focused. In the Middle Ages, catapults shot rocks into castle walls. A catapult is a really huge lever. A simple lever is a long rod or board that moves on a fixed point called a fulcrum. The load is the object you need to lift. The effort is the force you use on the lever. Some catapults were designed to shoot arrows or spears at enemies during a battle. I know some of you all built marshmallow catapults for your science fair. Fulcrum, load, and effort. All levers have a fulcrum, load, and effort. You can change the mechanical advantage of a lever by moving the position of the fulcrum. If you move the fulcrum closer to your load, you can use less force to move the load, but you have to apply that force over a greater distance. We'll look at some pictures to help understand what on earth that means. Levers are helpful for changing tires. The lever used to loosen bolts on a car's wheel is called a tire iron. You use a lever when you play on a seesaw. The order of the fulcrum, load, and effort determines what kind of lever you have. In a first-class lever, the fulcrum is between the load and the effort, like a seesaw. A seesaw is a first-class lever. So is a crowbar. In this type of lever, the effort pushes down for the load to go up. Like a pulley, this simple machine changes the direction of the force needed to move an object. Now, when we were talking about making that work easier depending on the position of the load, the effort, and the fulcrum, think about inching in closer on a seesaw or farther away. Think about pulling your tire iron or your crowbar from here versus pulling it from the back. You already instinctively know which one is easier, so that will help you out with that relationship. Moving together. In second and third class levers, both the effort and the load move in the same direction. The load is between the fulcrum and the effort in a second class lever. When you lift it, your load lifts too. For example, when you lift a bottle opener, the cap comes up. When you lift a wheelbarrow, you lift the materials in the wheelbarrow too. A bottle opener is just one of the many useful levers commonly found in people's homes. The first World Series was played in 1903. A baseball bat may not seem like a lever until you notice how it hits a baseball. In a third-class lever, the effort is between the fulcrum and the load. When you swing a baseball bat, you're using a third-class lever. The fulcrum is the base or handle of the bat. The effort is your hand pushing it forward to swing. The load is the ball that you send flying over the fence. Depending on whether it's first, second, or third class, the fulcrum, the effort, and the load may be in a different order in these levers, but they're all levers. Now we're ready for the big truth. So many simple machines. Amusement parks are filled with fun, but did you know they're also filled with simple machines? Next time you are at an amusement park, take a look around. What simple machines can you spot? Here are a few to get you started. You need inclined planes to zoom down roller coaster hills. Pulleys make the flags fly high. Some rides, like the pirate ship, are levers. A winding water slide is a screw shape. The Ferris wheel is a big wheel and axle. The plastic forks and knives at the bar are wedges. We can find simple machines both big and small at an amusement park. Ooh, I can't wait till we get to go to those again. That is the end of chapter 3. Thanks for listening to a chapter all about levers.